We now proceed to our last day of AP Calculus Review, Day A of AP Review, Areas and Volumes Between Curves, aka Differential Geometry. Alright, so recall that for an area between curves and volumes of bases, okay, the area is obtained by subtracting the area between the lower function g of x and the x-axis from the area of the higher function, aka the area between f of x and the x-axis, okay? So the area is the integral from a definite integral from a to b of f of x minus g of x. Okay. The method that we use, we locate the points of intersections. We use a test point between the points of intersection to determine higher and lower functions, aka with higher function f and lower function g, and then we integrate. For volumes of bases, we determine the area a of x of the cross section. Again, those areas should be in your notes, and you can reference the notes for Unit 6.1, or excuse me, Unit 6.4 for the specific areas for the specific types of cross sections. We integrate to obtain the volume, the area of our cross section a of x. We get a infinitesimally small volume dv by multiplying a of x by d of x, aka the cross sectional area times the thickness dx, and then we integrate that from a to b to get our whole entire volume. Volumes of revolution, the washer method. Again, the idea is we find the volume of each washer. dv is going to be pi of f squared, where f is our outer function, minus g squared, where g is our inner function radii. Okay, so that gives us the area of one of the washers, and then in order to get the subsequent volume, we multiply by d of x, the thickness of the washer. We integrate dv to obtain the volume. V equals pi from a to b, f squared minus g squared d of x. The same methodology, it considers the same methodology of area calculations, except you must take into account the axis of rotation. So recall that if the axis of rotation is y equals a, for a horizontal line y equals a, you need to use test points in order to determine what is your outer and inner radii function with respect to the axis of rotation. This method should be used when the axis of rotation is perpendicular to the volume cross-section dv, as we went over in class. Lastly, we get to the shell method. The idea is we find the volume of each cylindrical shell. Okay, the height is f of x, the thickness is d of x, and the circumference is 2 pi times the radii, which is going to be x. If we have a lower function g of x, then our height is going to be f of x minus g of x. Okay, we integrate the volume dv to obtain v, so it's going to be 2 pi times the integral from a to b of x times f of x, or f times f of x minus g of x. It carries the same methodology of area calculations, except you must take into account the axis of rotation. Okay? So if our axis of rotation is a vertical line x equals a, remember that we have to modify our radius x in order to reflect that new axis of rotation. So this method should be used when the axis of rotation is parallel to our volume cross-section dv. Okay? Test-taking tips. So test-taking tips. Who would win? A potato baked at 91 degrees Celsius or 200,000 students taking the AP Calculus exam? Hopefully us. Hopefully not the potato. On test day, there will be conceptual questions, mathematical questions, conceptual and mathematical questions, and questions that you do not know the answer to, and that is fine. Although ideally we'd like to aim for 100%, realistically nobody's ever going to get 100% on this exam. I think one person did it once, which is like, what the hell, dude? So there are going to be questions you don't know the answer to, and that's perfectly fine. You're not expected to get 100% on the exam. You will come out of the test stressed, anxious, and second-guessing yourself. Please don't worry about that. That's natural to any high-stakes exam, especially the AP Calculus exam. My best piece of advice for you is that when you walk out of the exam, just let it go. There's nothing more you can do to change the exam, and you've survived AP Calculus. So there's no need to stress. The test is out of your hands. There's nothing that you can do. Other test-taking tips for the multiple choice. The structure, part A, 30 questions, calculator not permitted. You have 60 minutes, which means you have 2 minutes per question. I recommend 1 minute for conceptual questions and 3 minutes for mathematical questions, roughly assuming a 50-50 split of conceptual and mathematical. Part B is 15 questions in 45 minutes where you have a calculator permitted. That means you have 3 minutes per question. Okay, so that should be your pacing. You should have an internal clock. We've done enough testing at this point of the year that you should have that internal clock set into your body. Okay? Tips, pay attention to what the problem asks for, i.e. the phrasings from the essential information packet. That will help you recognize key types of problems, and then that will also act as a sort of Pavlov's bell that causes your brain to recall a certain problem-solving strategy for the problem at hand. Take into account the subtle, seemingly unimportant details, i.e. the function f is strictly increasing, okay? F prime of x is greater than 0, okay? If the problem says a twice differentiable function f has a property that f del prime of x is greater than 0, that's telling you f is concave up, which will be used at some point in the problem. So please make sure you pay attention to the subtle details. Test taking tips, take it from experience. Free response questions, structure. Part A is 2 questions in 30 minutes, graphing calculator permitted. Part B is 3 questions in 60 minutes with no graphing calculator permitted. So in the first 30 minutes of your free response section, okay, focus on answering part A first. Once the first 30 minutes are up, you can still work on part A, but you can no longer use a calculator for part A. So use those 30 minutes to focus strictly on part A and use the calculator as need be. Okay, get as much done with the calculator as need be in those first 2 parts. After 30 minutes, you can still go back and work, but make sure that the questions, make sure if you're still working on part A after the 30-minute calculator part is up, make sure that the questions or parts that you're working on are parts that do not require calculators to answer, okay? Use time recommendations for questions that are assigned based on weighting of points. So all problem-solving steps used to arrive to your results. Write down explicit equations with variables, not just numbers plugged in, as these are often worth points. In addition, if it asks you to explain why something happens or explain your justification, make sure you state the proper mathematical conditions. AKA, if it asks you why is a function increasing over a certain interval, do not just state the function's increasing over this interval. State that the function's increasing because the derivative, or first derivative is positive over the interval. As an example, be as explicit as possible, just like we've practiced throughout the year. Attempt every section, even if you blank on that section. There's no penalty for incorrect answers, and a Hail Mary is a lot better than no response at all. And by that sound, we have arrived to the end of our review video.